There are two problems on page 98 that I'd like to go over because they're pretty interesting problems. And one is problem 107. The other problem is 108. So number 107 says that we have a 34.5 gram piece of gold, a gold nugget, and it's dropped into a graduated cylinder containing water. So we're taking this guy and we're dropping him into a graduated cylinder. There's my version of a graduated cylinder containing water. And by how many milliliters does the measured volume increase? The density of water is 1 gram per milliliter. The density of gold is 19.3 grams per centimeter cubed. So the density of gold equals 19.3 grams per centimeter cubed. The density of water, as you know, is 1 gram per centimeter cubed. So here we have the mass of the gold, and here we have the density of the gold. Essentially what we're looking for is the volume of the gold. And in water displacement, the level that the water rises, or the increase in volume that you would see in the graduated cylinder when you drop a sample in there. Okay, when we drop our gold sample in there, the water volume is going to go up. Okay, that increase in volume is going to be equal to the volume of the sample. So we're starting out with 34.5 grams of gold. I want to find volume. Well, this is another circumstance where I can use the density of the gold as a conversion factor. Okay? I want to find volume that's in centimeters cubed. So I know that 1 centimeter cubed for gold contains 19.3 grams. By putting centimeters cubed in the numerator, that's the unit I'm converting to. Grams here in the numerator and grams here in the denominator are going to cancel out. So grams here cancel out. I'm left with centimeters cubed. That's the unit that I want. So when I do my math, I'm taking 34.5, I'm times 1 over 19.3, which is the same as 34.5 divided by 19.3, and I get 1.79 milliliters. So my water is going to rise by 1.79 milliliters in my graduated cylinder. Remember that we always want to put our answers in a nice neat box, so I'll do it there to remind you. Now, number 108. Equal amounts of mercury, water, and corn oil are added to a beaker. So in order to do this problem, we have to know the densities of these substances. So the density of mercury, okay, mercury's symbol is Hg, is 13.6 grams per centimeter cubed. The density of water, by now you should know that, is 1 gram per centimeter cubed. The density of corn oil, that's the stuff you would use for cooking, is 0.922 grams per centimeter cubed. And the density of sugar, as in a sugar cube, is 1.59 grams per centimeter cubed. Okay? So if we put these liquids in a beaker, we need to describe the arrangement of the layers of the liquids in a beaker. So here's my beaker. Oops. That's a bit of a lopsided beaker. There's the bottom of my beaker. Okay. The heaviest liquid is going to end up on the bottom. So my mercury, when I pour it in, is going to end up down here. The next dense substance, which is my water, is going to end up above the mercury. And the corn oil is the least dense and is going to end up on top. So here's how they would be arranged in the beaker. Now remember that we call this a density column. And I've showed you one or two density columns in class. I also did another tutorial where you take a look at density columns. Now we need to think about what's going on with that sugar cube. So what happens if we drop the sugar cube into this density column? And here's its density, 1.59. It's between the density of mercury and water. So when we drop the sugar cube in, what it's going to end up doing is, since it's greater than the density of water and it's less than the density of mercury, it's going to float between the layers of mercury and water. So it's going to end up somewhere in here. Here's my sugar cube. Okay. Over time, what's going to happen to that sugar? Well, since it's in the water there, it's going to dissolve in the water and we'll no longer see it. Okay, so there's a density column. Remember that all liquids will arrange themselves from most dense to least dense. If we drop solids in there, okay, we can find out really what the relative density of the solid would be by its position within that density column. Or if we know the density of the solid, we could predict where it would end up in that density column.